Drop an apple, heavy keys, or watch a meteor streak across the sky, and the result is the same. The object is plummeting. Most people assume this happens because the Earth acts like a giant magnet, generating an invisible force that actively reaches out to pull everything toward its center. Sir Isaac Newton codified this observation, defining gravity as a universal attraction between masses. It is a concept that has defined our understanding of physics for centuries. In reality, gravity does not work as an active downward pulling force. If you are not being pulled toward the Earth right now, why do things hit the floor? Our basic sensory perception of falling is an illusion. To find the real mechanism, we have to look past the objects themselves and examine the invisible framework of the universe. Think of the vacuum of the universe as an invisible, woven framework. This three-dimensional grid fills the entire cosmos. Albert Einstein called this spacetime. It is a dynamic geometric fabric that dictates how everything within the universe moves. The entire system follows one fundamental rule. Mass tells spacetime how to curve, and spacetime tells mass how to move. We can only explain why an apple falls by first seeing how massive objects manipulate this geometric fabric on a much larger scale. In an empty region of the cosmos, an asteroid travels in a perfectly straight line at a constant speed, because the space around it is flat and undisturbed. Introduce a dense object like the Sun, and the fabric reacts. The immense mass of the Sun stretches and warps the geometry of the grid, creating a deep cosmic valley. When a smaller body like the Earth attempts to travel past this region in a straight line, it encounters the warped lines of the grid. Because the space itself is curved into a sinkhole, the straightest possible path for the Earth becomes a circular loop around the depression. The Earth isn't tied to the Sun by a magical rope. It is simply in free fall, following the natural geometric slopes created by the Sun's mass. What we observe as a planetary orbit is actually a passive journey through the invisible curvature of space. This same logic applies when we shift our focus from the solar system back to a single apple tree on the surface of Earth. When an apple detaches from a branch, there is no downward force reaching up to grab it. In the framework of general relativity, freely moving objects experience zero acceleration. As it begins its descent, the apple is effectively weightless. The reason it moves at all is that Earth's mass doesn't just warp space, it also warps time. This warping creates a gradient where time physically flows slower the closer you get to the planet's surface. A clock at the roots of the tree ticks slightly slower than a clock at the top of the branches. Objects naturally follow the path that maximizes their time. This geometry drives the apple toward the region where time moves slower, physically pushing it down the temporal gradient. Ultimately, the apple hits the ground because it is simply sliding down a steep slope in the fourth dimension. Consider your own body right now. Whether you are sitting or standing, you are currently positioned within that same temporal gradient. The curvature of spacetime dictates that your body should follow the natural geometry of the universe and free fall toward the center of the Earth. You feel this as the heavy pressure of weight in your body. The solid ground beneath you is physically accelerating outward against the curvature of spacetime. It pushes against your shoes, with enough force to prevent you from following your natural path. Gravity is a passive geometric reality. Your feeling of weight is the Earth's surface actively blocking you from sliding down the curve of the universe. Understanding these hidden mechanics fundamentally changes the way we view our own existence and the ground we stand on. If this deep dive into the fabric of reality changed your perspective, subscribe to Core Logic and hit the like button. Share this video to help us continue decoding the universe. Mass bends the fabric of space and time, but a dying star's extreme density completely tears through the geometry of the universe. In our next episode, we are exploring the exact anatomy of a black hole. You do not want to miss it.